These are your 12-6A notes on circular functions. This will be the last section before we test over the concepts in Chapter 12, and then we'll finish off the second half of 12-6B. It sort of relates to the second half of what we'll quiz over the rest of Chapter 12. And so in this section, what we learn is that we're back on the unit circle, and if I have a point on this unit circle, remember, the reason they call it a unit circle is that the radius of the circle is 1 unit. If I were to make an actual reference triangle with that point P and call it theta prime, or theta, I should say, the amount that this point goes over would be the adjacent side to that angle, and the amount that the point goes up would be my opposite side. And so my x and y coordinates of this point end up being the side values of that right triangle. So when I go through and I figure out my sine value of theta, I'll just call that theta rather than theta prime, like that theta. It is equal to the side opposite, which is y, over the hypotenuse 1. And since the hypotenuse is 1 unit, it's just going to stay y. So the y value in that point represents the sine of theta, because we're on the unit circle and because the hypotenuse is only 1 unit long. If we do the same thing with the cosine of that angle, it's the side adjacent, which is x over the hypotenuse 1. And again, because the hypotenuse is 1, x divided by 1 is just x. And so the x coordinate is your cosine of that angle. So you're actually looking at the sine and cosine values when you're looking at this ordered pair. This is only true if they tell you that point P is on the unit circle. So if they give you an ordered pair and they tell you that that ordered pair is on the unit circle, you know that the x value is the cosine and the y value is the sine. The only difficult thing with this is that you have to really be careful, because whenever we list these things, we always want to list them sine first, then cosine. But in the ordered pair, it's in the opposite order, because the opposite side is y and the adjacent side is x. So just think of it as alphabetical. Cosine comes before sine. So we can actually use the table of values that we have on our circle sheet and all of those exact trig values to fill in this entire circle. The ones I really want to concentrate on are the quadrantals, and kind of talk about, now that we have this idea of the unit circle, we can actually calculate quadrantals. We kind of skipped over those up to this point. And so if I look at my radius coming over to 360 or 0 degrees, my radius is 1 whole unit. This represents point P. Where point P is located is it went over 1 to the right, and it didn't go up or down any. And so the ordered pair 1, 0 is telling me that the sine of 360 degrees then is 0, and that the cosine of 360 degrees is equal to 1. If we have those two values, we can actually find all the other values of the trig functions. And so we have sine and cosine, and we can find the rest of quadrantals. If I go up to 90 degrees, so if I take this point P and I rotate it up around the unit circle up to 90 degrees, 90 degrees would be the radius of 1 going straight up and down. And so my ordered pair that matches that quadrantal would be 0, 1, and we're looking at the cosine and the sine of 90. If we rotate that around all the way over to 180, okay, it still has a radius of 1, and it went to the left 1 unit, so that would be -1, and it didn't go up or down any, so you have 0. So you might be seeing a pattern with the quadrantals, is that you get a lot of 1s and 0s, or -1s and 0s. When we finish this off and rotate it down to 270, Again, that's going to be a radius of 1 unit, but it went down 1. So my ordered pair is 0, -1. And so you can see again that you have a 0 in every single one of the quadrantals. Whether it's sine or cosine, one of them is going to be 0. And then the other one is going to be 1 or -1. And we'll explain that. I'm going to do 2 of them together, and then you're going to do one as your lesson summary. Let's just quickly go through the first quadrant here, and then I'm going to have you finish off the rest on your own. So for 30 degrees, if I were to draw the 30-degree angle, and so I have my radius going up to point P at 30 degrees. I drop my perpendicular. Okay, the amount that I go over and up, here's my 1. Okay, now I know, looking at my chart, that the sine of 30 is a half, and the cosine of 30 is the square root of 3 over 2. So actually what that tells me is that my y-coordinate, how much I'm going up there, is a half of a unit, and how much I'm going over at the bottom is the square root of 3 over 2. That's about 0.8. Square root of 3 over 2 is about 0.8, so it's just shy of 1 whole, which accounts for this missing piece right here of our radius. If I go up to 45 degrees, the sine and cosine are both the square root of 2 over 2. And that's just under 0.8. I think it's like 0.6 something. So it's a little bit bigger than a half, but not quite as big as the square root of 3 over 2. And that makes these two equal. So you'd have the square root of 2 over 2 and the square root of 2 over 2. And then 60 degrees just flip-flops what we already had occurring at 30. So at 60 degrees, you go over a half and you go up the square root of 3 over 2. So that flip-flops, and that's why cosine of 60 is a half, and sine of 60 is the square root of 3 over 2. Now those same 3 values are going to apply over in these other quadrants, but they're going to move over to the left. And so all of your x-coordinates are going to be negative for these values. Your y-coordinates will still be positive because you went up that many units. In the third quadrant, both of these values will be negative. But they're going to be the same values that we have in that first quadrant. You figure out is a 30, a 60, or a 45-degree angle. And then in the fourth quadrant, our y values will all be negative. So we'll kind of talk about that tomorrow. You guys can finish that up tomorrow, or you can actually copy it tonight. It really doesn't matter. You're just using those same values. So part of your homework is going to look like this. They tell you that theta is in the standard position, and then it lies on the unit circle. So point P lies on the unit circle. Has to be in standard position. They're never going to give you any that it's not. But that unit circle is so important. So they're asking you to find the sine and cosine. So the sine of theta is equal to the square root of 3 over 2. And the cosine of theta is equal to -1/2. Here's your cosine, here's your sine. That's all you have to do. It's just interpreting, understanding what this means. Sine of theta is 0.6. Cosine of theta is equal to 0.8. And the last one, the sine of theta then, if this is on the unit circle, would be a half. And the cosine of theta would be the square root of 3 over 2. That's all. You don't have to figure out how big the angle is. You're just interpreting the ordered pair. So let's talk about the actual all 6 trig values for the 90 degrees. So if you draw this for 90 degrees, I'm going to draw just a quick little sketch of 90 degrees. But instead of drawing a reference triangle, there is no triangle because we're on one of the quadrants. So I'm going to draw a point at 90, call it point P, and I'm going to label point P as if it was on the unit circle. So here's my 90-degree angle. Okay, that's a unit 1. So I went over 0 and I went up 1. Now that I know that I'm on the unit circle, okay, so I'm going to draw my unit circle so I know that that's 1 unit. Based on what we know about the unit circle and the ordered pair on the unit circle, I know that the sine of 90 degrees is 1. The cosine of 90 degrees will be 0. Now, if we actually had a reference triangle to go by, if you just go back to that last screen really quick, to find the tangent, if you look at 30 degrees, tangent would be the side opposite, which is your y value, over the side adjacent, which is your x value, y over x. And if you look at it, your y value, it would just be the 1/2, which is your cosine, and then your x value, this is your, I'm sorry, I have that screwed up, look at the wrong one, x and y. And so what it becomes is just sine over cosine. If you put the sine over the cosine, because your y value is the sine and the cosine is your x, if you just put sine over cosine, you will have tangent. And so that's exactly what we're going to do. To find tangent of 90 degrees, we're going to put the sine value, 1, which is my side opposite, over my side adjacent. Whenever you divide by 0, though, that doesn't exist. So tangent is undefined. The tangent of 90 does not exist because to get it, you'd have to divide by 0. The cosecant of 90 degrees is the inverse of the sine. So if you take the inverse of 1 and you flip 1, you get 1. The secant of 90 degrees is flipping 0. Well, if you flip 0, 0 is now in the numerator. When you flip 0, I don't care what number goes on top. If you have 0 in the denominator, again, you have another undefined term. And cotangent, if you flip your undefined term, the reason it was undefined is because 0 was in the denominator. So to get cotangent, 0 is now in the numerator. So this is what you're going to find happening on quadrantals. Every single time, you'll get a 1 twice or a -1, depending on what quadrant you're in. You'll get 0 to show up twice, and you'll get undefined twice. It's just depending on what quadrantal you're finding where they show up. There's no rhyme or reason to this. So when you flip a 0, it becomes undefined. When you flip undefined, it becomes 0. When you flip a 1, you get 1. And when you flip a -1, you get -1. So let's go ahead and try this again with 180 degrees. So again, we're going to draw a picture. We're going to make our quadrantal angle of 180 degrees. So here's my 180 degrees. Make my unit circle. I want to know that that's 1 unit. By putting that 1 there, we know that we're talking about the unit circle. So this is a point on the unit circle, and my point is at -1, 0. I went to the left 1, and I didn't go up or down any. So the sine of 180, this is 180 degrees, by the way. The sine of 180 degrees is equal to the y-coordinate, which is 0. The cosine of 180 degrees is equal to the x-coordinate, which is -1. Tangent, put sine over cosine. So put these two values over top of each other. 0 divided by -1 is actually 0. If you don't know if that's undefined or not, you type it into your calculator and it will give you 0. When it's undefined, it'll give you an error message. Cosecant of 180 degrees, you flip the sign. Well, when you flip 0, it becomes the denominator, so that's undefined. Secant of 180 degrees is when you flip -1, which will give you -1. And cotangent of 180 degrees is when you flip the 0, and when you flip 0, it's now in the denominator, so you get undefined. Let's just review our answers. I got 2 zeros, I got 2 -1s, and I got 2 undefineds. So that is a classic quadrantal. They're a little bit different. You're going to get 1s or -1s. You're going to get 0s and undefineds. Okay? The other thing that they're going to do here is they're going to give you some simplification tools. They're going to give you trig values, and then they want you to figure them out based off of what you know. So in this section, they're going to start giving you the loop-de-loop angles, cosine of 600 degrees. You do the same thing you normally would. 600 degrees, you kind of do a little bit of math and realize that in order for your degree to be 600, we went above and beyond the 360. So if you do a little bit of calculations, you know that you went 360 degrees, then an additional 240. So we're going to go around and around, draw our angle, and I know that 240 degrees is like a 60-degree angle in the third quadrant. So label your angle, 600 degrees. But again, we're still going to use theta prime. Theta prime is this little angle here. Here's my reference triangle. We're going to talk about theta prime. And so theta prime is equivalent to, the first thing you have to do is figure out the degrees. So you have to subtract the 360 first. So theta prime, it just takes a little bit more work now, is equivalent to 240. Now we're going to take the 240 and subtract the 180 because it's in the third quadrant. Now you can get down to the 60 degrees. So when you go more than one time, you just got to adjust a little bit longer to get down to that positive acute angle. So the positive, subtracting 360 just means it was a coterminal. Now that I have theta prime, I can actually make my last statement that says we're trying to find the cosine. The cosine of 600 degrees is going to be equivalent to the cosine of 240 degrees, because that's what it was quadrantal to. And the cosine of 600 degrees then is equivalent to the cosine of 60 degrees in quadrant 3. And the cosine of 600 degrees then, if you look at the cosine of 60 degrees, that's a half. We're in quadrant 3, so all students take calculus. The t in quadrant 3 tells me tangent is positive, so this is going to be negative. And actually, now that I think about it, if you don't want to do this, you don't have to do the 240 part. We did the extra step in theta prime, showing that 240 gets us to 60. And there's the work. So just a little bit of extra work there. Sine of 9/2 pi. Okay, when we draw 9/2, the halves tells me that we're going to land on a quadrantal. I just got to figure out what quadrantal because it's a little bit bigger. So if I'm talking in terms of halves, I should probably figure out 2 pi to subtract 2 pi. So this would be 2/2 pi, and this would be 4/2 pi. So when I figure out my quadrantal, I need to know how much I went around. So if I do 9 minus 4, that gives me 5/2. I'm still too big. I'm at 1/2 pi. So this one around, when I draw this angle, this would be 4/2. This would be 8/2. This would be 9/2 pi. 9/2 pi. Okay, but it's going to be the same thing as 90 degrees. So if you make a unit circle, and draw that this point right here is at 0, 1. For 90 degrees, since I'm looking at sine, I have it right here. There's your sine, there's your cosine. The sine of 9/2 pi is the same thing as the sine of pi over 2. I don't need to know what quadrant it is in because we don't have a quadrant. And so the sine of 9/2 pi is equal to 1. The quadrantals, after you draw the picture, there isn't as much work as the others. There's no theta prime. You deal with a point on the unit circle. The only comment you have to make is that you know that it relates to the 90-degree quadrantal and not 270 or 360 or 180. The last problem I want to show you here is you just start using some substitutions. So use your table of values. The sine of 30 is a half. So they want you to bring in a half. They want you to replace cosine 60 with a half. We just know that from that sheet. And then you just do a lot of simplifications. So after you substitute, 2 times a half is 1. 4 times a half is 2. And all divided by 8. And so in the end, this becomes a fraction, 3/8. So they're just using trig values as values that you're going to do a lot of fraction simplification. All right, so from here, I want to just identify the sine and cosine of the angle formed that lands at point P, 0.5 and negative 0.7. And then I want you to find all 6 trig values of this last quadrantal. We've done 90. I think we did 180. I think we did 360, but we never did 270. So let's go ahead and do 270 here. Good luck.